Just starting off again, I guess. It's now Saturday night, so Saturday evening, so alright, good deal. Alright, so we're going to work on the Heuristic Search Planner. So we got this Breadth First Search Planner. I didn't test if this actually worked, so I guess that'd be the first thing to try. So I will just start this up. And I'll just go through each of those and see what happens. Okay, yeah, it just gets a plan. And the first would be the... Okay, eat cake. And bake cake. Alright, cool. Alright, so that looks like that's working just fine. Now we gotta do HSP. So HSP is gonna use a priority queue. I don't know exactly how to do a priority queue. I know I looked it up earlier, but let's see what we got in here. Priority queue C#. What about that? MSDN. If so, then a sorted list may be a good bet since it can handle all of your querying for you. No need to get a thread by unique ID, so many. Alright. Reading about priority queues. Alright, so the solution, a queue, yeah. Okay, so what are they doing? They're doing priority worker role, queue manager. Should I do something like a queue manager? I don't know what a queue manager is. Let's go down this rabbit hole a little bit. Queue manager. C#. I don't like where I'm going with that rabbit hole. Alright, back it up. Net implementation of priority K, aka heap. Maybe I'll just look up a C# heap. Sorted list. Okay. I guess I'll try sorted list. What is a sorted list? Maybe if I go to Visual Studio, this will make sense. So we got this HSP planner, which I think should be very similar to the BFS planner. So what I'm going to do is just take this code, and I'm going to go to HSP and kind of just replace this code. And we'll just call this HS Planner. And HS Planner will have this sorted list. Let's see how this works. I really don't know. Okay. I'm gonna go say int, and yeah, that seems fine. I like to do this stuff in the constructor, I think. That seems good. So what do we got here? Dot add, dot pop. What do we got? Dot DQ, dot well, okay, for sure we know we gotta add maybe like a 0 and a Q. Let's see what a sorted list do. Sorted list C#. Tell me more. Alright, so sorted list, man, yeah, .NET Pearls is definitely the site I like to go to. So when you say sort it that try to get value pearls. No, that's not what I wanted. This one, loop over to sorted list. Console at right pair. Yeah, this is the one I wanted. So you did 1, 2, 3. Okay. So I'm gonna kind of just follow that exact same thing. Yep. I am going to go the other way, I think, with this. I think I'm going to do that and 0. And let's just go the other way here. State space node int. Let's go ahead and do the same thing here. State space node and int. And what do you want from me? You want a I think we should make a new state space node. It's gonna be no, we don't need to make a new state space node. Root and 0. Okay, that's cool. So we got a new state space node there. How do we remove something from the sorted list? I think we just say state space node dot we'll call this Q dot get or Q0, I guess. No. This is not how I wanted this to go. first? Yeah? I don't know. I want the first one. I want to pop it. Let's see, min. I saw that. What else we got? Add. Shoot. Let's go to the other thing. Sorted class list collection. Maybe that will tell us something. Alright, so those are constructors. What the properties are, yep, capacity, count, is fixed size, all of that seems great. We have add, clear, clone, contains, copy to equals, finalized, get key, get type, get value list, index of key, index of value, returns a zero base index of the first. Okay, so this is what I'm going to do. Sorted list as priority queue C#. Okay. Priority queue. Yep, that's a good. I'm just gonna read through this. Okay, so this is using a sorted dictionary. All you're doing is, if not, try get value key. Don't know what I'm thinking here. Dictionary.key.first. And then you grab the dictionary key, DQ. Looks pretty good. Basically, they're making queues at different levels, which is not bad, not bad. I kind of just want to see what the sorted set is, now that that was kind of mentioned. Sorted set, C#. Okay. I see. So where's the comparator? How do I change the comparator? That's the last thing I kind of want to know. Overlaps, intersects with, min, max, proper subsets, get view between, contains, reverse. Let's go back to this guy now. Alright, so we have simple priority queue. Alright, this guy was like, he's a sorted set class with the custom I compare. Okay, something like this would be good. Alright, come on, priority queue. Should I just copy and paste this priority queue, the one that was on here? Maybe. That's a heap. This is not the same one I was just looking at. Wait, who was I looking at? Now, add new item. Priority queue. Alright, and I can just paste this here. And so, let's see, Control KD. This priority queue is, yep, element and key. Alright, so element's the type of the actual elements that are stored. Key is the type of priority. It probably makes sense to make it int or long, but any type can be. Okay. So int's good, I think. Yeah, let's do that. Let's go with it. Priority queue. This is the kind of a node and an int, and we'll call you Q. And then when we're making a new one, we can just say new priority queue state space node. Oh, you already got it. So I can just do that. I gotta give a selector. Okay, so what do you want for my selector? A function. A function that does what? A selector encapsulate method. Okay. How do we make a selector class? Int selector return int or default. Okay, selector. I don't know what this thing wants. State space node. You gotta help me out, buddy. I'm not really doing so good here. So priority queue is failing me pretty bad. Sorted list sounds good. sorted list, get first item. Okay, get by index, sure, I can do that. Alright, so let's do that. Sorted list, sorted list, delete the selector. We got that going for us. Get by index, what did he say? Dot get by index. You don't exist. So that's a lie, right? I can always do that, I guess. Didn't want to do it like that, but we can. So since I'm having trouble here, I can just say q.keys 0, right? Maybe I'm wrong here. Sorted list. Alright, so here we go. Sorted list. We have an int and string. 1, 2, 3, 4, 5, 6, 7. So there we go. Sorted list out of that. Let's do something like that. Alright, so we're gonna go with the int, then the space node. Flip that for me here. And then we'll flip that here. 0 root. And so now we can say q keys 0. Alright, cool. So you get the first key, give me the key of that. Awesome. And this is what I gotta do next. Q.remove at Q.keys 0. So that's me like popping, I guess. Alright, so then we got a enqueue, which is not really enqueue. We just got a dot add. This will be an int, which will be get cost of child, and you can be the whatever I was gonna do, child, right? And then anyway, this is what we're gonna be implementing. But for now, it will be just 0. So this should be a breadth first search, right? If I just put in 0. save this, but I'm actually not going to use it. Alright. Here we go. So going back to benchmark, I'm going to go here. That part should be fine, except the problem, right? We got to use the SS problem. And we got to use this find next solution. Alright, so I'm going to hit start. Hit F10, that's our planner. Okay. So we should totally have a queue. The sorted list. And our value is a state, yes. Okay, hopefully our next node will be that. Then we can remove our queue. Yep. Node.expands. Is it true? If it's not, then for each child, we need to try a harder yeah. Okay. So we got cake domain here. What other domains we got? Maybe if I went to... Here we go, we got rocket domain. Let's try that one. Yep, so we got rocket domain here. So what if I just did that? Rocket domain and rocket problem. So if we go back to benchmark, we just did rocket. What do you think? Rocket. Rocket. And we copy if newer. Yeah, awesome. Alright, so this part is just going to make some new list, which is cool with me. So we should have a queue in here with one item, and that's going to be with key 0, yep, and the value of that, awesome. Alright, so here we go. We're going to remove this queue, so that's now 0. Expand the node for each child. Oop. What happened? An entry with the same key. Oh, so we can't do the same key. That's going to cause a problem because I definitely need the key. I need multiple things to be of the same key. So I do like what I started, or not that I started, but someone else started. So we're going to just go ahead and say a new item. Yeah, I don't even know what to call it. Priority queue, C#. I don't care what MSDN. It doesn't have to be MSDN. Just give me something awesome. Just give me a darn priority queue, please. Somebody, anybody. Priority queue. Here we go. Priority queue node. Here we go, priority queue. Okay. Yep, this is good enough for me. That and a priority. Okay, fine. Seems like how I would do it. And that's a bad thing because I'm pretty amateurish on this. So okay, back to the U. Add a new item. Priority queue. Just for now, it's going to be this crazy thing. I will kind of look at this. So we have a list of T. Yep, that's great. Values and priorities. Int. I don't know if I really need that. Would like just public int count, which will just, oh, better yet, get return values dot count. Nice. Okay. In queue, so you put a new value. New priority, okay. DQ. Do I have to put that? Remove the item with the largest priority from the queue. I'd rather not have to put anything. I'm just gonna return T, yeah? We'll call this T, right? T top value, int top priority, and just return top value. Okay, cool. I think that works. Alright, that seems fine. That's good. Alright, so we go to HS Planner. Now we're gonna make this a priority queue again. This fake priority queue that we made. Priority queue. And it's just gonna be a state space node. Yep, no problem. We'll go up here, make you a public class. Excellent. And so now, if you don't mind, let's make you a priority queue, state space node. We don't have to actually put in a number. Yeah, we do. We have to put in a number. So it's NQ maybe? NQ root, and new priority will be 0. And now we should be able to say Q dot DQ nothing. Excellent. And then NQ child get cost of child. Okay, I think that should be it. Let's see what happens. So this will be the rocket problem, so that should work. So here we go. You have 3 things you can do, I think. Alright, so you have 3 values, which are all state space nodes. Okay, cool. All with 0 for now. So you're going to just grab the first one, which I really don't know which one is which, so that's okay. So now you're down to 2, okay.
Sometimes I lie awake at night and the shadows changing on the hollow.
So this is breadth first search. I'm pretty sure. Doing it this way. Which is good. Alright, so it'd be nice if our state space node or search space node, if you don't mind, search space node, when we are going to string with this sucker, to string, nope, alright. Public override to string return. This is what I wanted you to return. You have an to expression. State dot to expression dot to string. I think that's what I want. So I can jump in here. So when I look at this node, yes. So this is the initial node. So cargo's at NOLA and rocket's at NOLA. So we're going to expand that. The child is rocket NOLA, cargo, and rockets. State space node. What else do you have? Do you have like a step that you took? You got a parent. I guess what I'd also like is plus a space plus a plan dot, I don't know what I want with the plan. I don't really want to add step. If I go to plan, yeah, just looking. HSP, no, let's go back to, yeah, state space node, back to the bottom here. Plan dot, there's no way to peek at anything, huh? Alright, first, turns the first element of the sequence. First step. Dot, to string, why not? If I didn't do that, would this still work? Yeah, okay. So if I hit play, F10, F11, really let's just jump here next time. Alright, so node is not what I want exactly. That part's pretty cool though. So okay, we're gonna check out load cargo first. Okay, so the bad thing is it's just giving us the first thing. It'd be nice to just get everything, right? So why don't we do that? So what if I just said this? String plan string equals this, and I just said for each step in plan string plus equals step plus some kind of comma, and then we just put in the plan string here, and maybe we can start it with this guy and end it with this guy, maybe. So this is a yeah, that should be fine. Alright, where am I? I'm here. I'm gonna hit play. I guess there's an exception for that first one. That's why it didn't show me, which is okay. What if I hit continue here? Say F10, here we go. No plan there, okay, cool. Load cargo NOLA, load fly cargo, fly NOLA, fly rocket NOLA. So okay, cool. So we're gonna get the load cargo NOLA. Next child is gonna be load cargo, unload cargo, okay. It's gonna be load cargo, fly NOLA, NOLA, yep. Load cargo, then fly rocket NOLA, London. That's the good one. Alright. But with the breadth first search, we're gonna go back to the other one where it's yes, fly rocket NOLA NOLA. It's only one step. And then for that one step, we're going to get all its second steps. So we're going to get the load cargo NOLA. Yep. We're going to get the load cargo rocket NOLA. Yep. Fly, oh yeah, I saw it. Fly rocket NOLA NOLA. Fly rocket NOLA London. Okay. And there we go. So yes, this is definitely doing breadth first search, which is great. And that's what, when you do 0, that's what you get. So that's a plus. So now we gotta do the heuristic, the HSP, which is where we get all the literals and we figure it all out, right? So let's do all of that. So where's that at? That's gonna be with I got it here somewhere. It's one of these. Try this one. That says planning graph. Here we go. This is what I wanted, because here is the juicy code. Somewhere around here. This is where the juicy code lives, right above all of this example. Here we go. This is the heuristic. So we're going to get every literal, set it to initial. Okay, cool. Okay, so this is what I'm going to do. Go ahead and I'm going to make a new class, new item. It's going to be an HSP node. HSP node. Don't know what you're going to have yet, but I know we're going to be using you. So, okay, HS planner. Okay, so look, we have a child dot state dot to expression maybe. I'm gonna look at this state. So you have a list of literals, which would be great to have. But you don't want to give that to me, do you? I'm adding it. Screw it. Public list of literal literals get, oh wait, we did that first one, get return literals dot, this is what I'm gonna do, new list of literals, and just put the literals in there. There you go. So you at least get a clone of it. So here we go. For each chicka literal in child dot state dot literals, so yes, we have a literal. We're gonna make new nodes, right? So we're gonna call this HSP nodes. So we're gonna have a list of HSP node literal nodes. I'll just call them nodes. Equals new. Yeah, sure. And then we're just gonna say nodes dot add new HSP node literal. Gosh, can I just say int dot max value? And that's it. That's how we handle that. Every literal that is true in the current state has a cost of 0. For each literal in yeah, I wonder what would happen if I just did that. Extend this. Yeah, how's the equals work on this whole thing? Literal is an expression, expression is an interface, and how do you do equals? You don't. Okay. Well, I won't ask further, really. Formula. Yeah, there's not really much we can do here. So, literal. It's an interface. Okay. Well, let's see, if nodes can you change type C#? Ah, okay, let's see. Very curious here. Convert base class to derived class. Interesting. Can use like an auto mapper. Okay. Decorator pattern. What's the decorator pattern? Alright, whatever. I am not I'm just gonna make, yeah, we have the HSP node, it has a literal, has that. could say HSP no, child. So for each of those literals, if literal, so what am I doing here anyway? What's the goal here? So we got the list of all the HSP. Okay, so yeah, now I remember now. Where's my state spacer graph? Okay, I gotta check if the literal is true in the current state. Oh yeah, so this is definitely not all the literals. This is just some of them. So let's see, generate a constructor here. Don't forget to make sure you have a set cost, int cost, and we'll just say max value equals cost, and really it's cost. And literal is literal, okay. And cost is cost. You're gonna be a void. You're gonna be an int get cost. You don't actually say that and just return cost. Okay, yeah, that makes sense. And then just to keep this all nice and consistent, alright, set cost. So we can now just say if literal get literal get HSP node literal nodes dot yeah, let's just generate a method. You're gonna give me a HSP node just get node, why not? Dot get set cost to 0. Okay, that's looking pretty good. And then basically all you do here is just for each HSP node and nodes, if node dot, we'll say get literal equals literal, return node. So we go here, get literal, return literal, public. Alright, so that's cool. Otherwise, return null. Dot equals literal. That's better. Yeah, that seems fine. So now we'll be able to get nodes. So for each literal, get node, set cost to 0. And cost is a conjunction. Okay. Alright, so for every step S, for every literal E in effect S, I'm thinking. So here, I don't know if there's like a root, get root. So if we go to state, not exactly what I'm thinking. Doesn't apply, is true, state. What about state space state or node? Children, visit it, state space. Node, count, visit it, count, expand it, get root. What's root do? Yeah, I don't know. So what am I trying to do? I'm trying to get all the effects, right? So in the state, no, it's actually all about the problem, right? So with the problem, there's steps, yep. Collect steps, collect. Yeah. I don't really know. I'm gonna go ahead and just say private. We still have SS problem or problem? Problem list of literals. At Q, we have a problem. Let's go ahead and save this problem. I thought the problem was saved here. Nope. The problem is just that problem. Yeah, equals problem. So that's a search, right? Public problem problem. All right. So oh, it's just problem though. Okay, that makes sense. Okay, cool. So yeah, I'm pretty sure if we're here, problem, where does it say problem as state space problem? For each step in this thing, do something. Okay. List of literals. Literal equal new list of literals. Okay. So we are gonna have to go back to our plane graph project. Plane graph this thing. Get all effects, which is going to be this crazy thing, and then we can go back to our HSP planner. Yeah, it's going to be a problem as state space problem dot steps. Alright, I might just leave it like that and return Problem. Literals. What do we think? That looks good? Alright, and then basically, when you get the node, no. We're getting the cost. Oh, yeah, we gotta do this every time we get the cost. Might help if we just do this once, right? So let's go ahead and say private list of literals. All literals. All literals equals get all literals. Alright, cool. And actually, we could probably just do this. Probably better if we did that. How about that? That seems good. Get all literals. Yes, so for every literal, all literals, we're going to set that to max value. For every literal and the actual state, we're going to set that cost to 0. That makes sense. So we got the first 2 lines. Okay, so we have a literal, and for every literal we're just setting everything to infinity, everything to 0. Now we got to start taking steps. So I guess I should keep a, I don't even know, like a dictionary of costs. Let's just do it, I guess. Private dictionary of HSP node and int. And we'll just call this previous costs. Okay, and then this is how we're gonna play it. I think for each HSP node in nodes, previous costs equal node dot that add, let's go ahead and say previous cost equals new dictionary. Okay, good enough for there. Add key, which will be node value, which will be node dot get cost. Okay, so now we got all the previous costs. Let's start making different costs. If while has not changed or has changed, while has changed, nodes and previous costs. Okay. For each step in problem, I'm just gonna put everything here, private list step, all steps. Here we go. And this is how I'm gonna get all steps. Get all literals, get all steps. And then just basically down here, private void, get all steps. This one's going to be easier. This one should just be all steps, right? All steps. We'll just say steps equals steps equals new list. Or better yet, I will do one better. Make you an immutable array. Immutable array of step. Oh, all steps. I guess that's a better name for it. All steps. I'm going to go ahead and put you up here and remove the space here, and then go ahead and make sure you get all steps first. So all steps, all literals, and do the rest. Okay. And now all literals, child literals, that's good, that's good. And then we can just say all steps and all steps. For each step and all steps. For each literal, in conversion util dot expression to literals. Expression is going to be all steps, I guess. Nope, it's going to be step dot effect. So for each literal in there, what are we going to do? Alright, so this is what we can do. Int current cost equals what do we say? Get node literal dot get cost. What's up? Oh, you need the nodes as well. Nodes. Alright, get node, or int new cost can equal 1 for each For each precondition in conversion util expression of literals step precondition. New cost. Well, first I'll say this: if precondition, if get node of precondition nodes equals, I'll just say get cost equals int.max value, then we can just do two other things. New cost equals int.max value and break. Otherwise, we can say new cost plus equals get node precondition nodes dot get cost. Alright, so that's cool. And then finally, new cost, let's see. Nope. What am I trying to say? Step? No, the node. What's the node? Get node literal nodes dot set cost math dot min. It's gonna be current cost or new cost. Yeah. That's the for each, that's the while. And then finally, return, we'll say cost equals 0 for each literal in let's do the conversion dot or conversion util dot expression to literals. So for each literal, cost plus equals get node literal nodes dot get cost. Then finally return cost. And that's it. Okay. Let's implement this guy. Alright, so we got a list of previous costs, which is cool. So for each node, in nodes, return false. Okay, if node.getCost does not equal previous cost dot node previous cost of node, yeah, return true. Has changed. Alright, good deal. So that's the has changed code. So let's see. Has changed. Cool. Do some stuff. I almost say let's move this inside, and I think I have to. Alright, so here we go. I'm gonna just clear it and just redo everything. Yeah, I don't even know if you need previous cost up here. So I just said, hey, you're just a new thing, only here. And we just called you previous costs. Okay. Yep, I'm gonna say that, or previous cost dot count is equal to 0. So we can clear nodes, add all the previous costs. Yeah, what is, and this is just another thing I'm going to do before I run this, is int test equals 5 plus int dot max value. Alright, cool. Let's run that too. Oh. Yep. Alright, I'm gonna hit play. Oh, you really shouldn't do this. Good eye, good eye. Alright, so test is that thing, plus 5. Yeah, I don't like that. Cool. Just checking. Making sure I was doing the right code when I said, hey, if you're the max value, just go ahead and continue being the max value. Which seemed to be the right thing to do. Alright, so here we go. This is where we're going to get a little crazy. Alright, so nodes is going to be this new list. I almost just say do this on initialization. So this part is going to be called initialize, create HSP nodes. And then really, this is how I'm going to handle it. I think I'm going to just delete it from here. Actually, no. Let's go ahead and just say nodes like that. Create HSP nodes is now going away. We put this in the constructor. So really, this nodes is going to be nodes, delete that. Nope, not what I'm trying to do. Generate a field for that. Awesome. And you don't even have to return this, because now you're just a void. Cool, so create HSP nodes. Really, this part, we'll just call it reset. Reset nodes. Awesome. Create HSP nodes, and then yeah, let's just, so that's that. Not quite. So this one's just going to be node, HSP node in nodes. All I'm going to say is node.setValue, set cost to int.maxValue. Cool. That's great. That works. Alright, so still gonna hit play. At this point, if I go to this, all literals is going to be every single possible literal. Cargo at NOLA, not cargo at NOLA. So there should be at cargo NOLA. Okay. In rocket and then not in rocket. Okay, that's all good. So that's great. All steps should be a bunch of steps. Cool. Nodes should just be, oh, okay. Let's go ahead and make something cool with the nodes, just so we're looking at it, we know what it is. Public override toString. I would prefer this string.format. Let's say the literal with the bracket and the cost, and then we can just say literal and what's the other one? Cost. Awesome. Okay. Cost. How about that? So we get to the point that I want to get to, which is this. If I look at it, if I look at all our nodes, yeah, we get this really high cost. Alright, cool. Alright, so Q for the node, wherever the node may be. Oh yeah, there we go. So that's the node, and that's the state and the plan. So that's doesn't contain our plan. Alright, so we're gonna jump in here. It's okay. At this point, we should have a bunch of nodes at 0, right? Ooh yeah, don't forget to reset that every time. Reset nodes. Awesome. Alright, so here we go. Reset nodes. Everything's at negative infinity or whatever. Yep, that is the nodes. So for each of these, set the cost to 0. So there we go, at rocket NOLA 0, and at cargo 0. Awesome. We're going to make a new dictionary of previous costs. Good call, good call. This is what I need to do. Here, I should check this one first. Oops. And then make the OR here. Everything looks good there. I'm pretty sure everything's looking good there. Yup. I'm gonna say yup here. Clear that out. Okay. Cool. We have 10 with all the previous cost. Excellent, excellent. Alright, so we'll be doing stuff now. So all steps for each step. We're going to be like, hey, for each literal, current cost is what? Alright, so I'm going to, current cost is that. Alright. Cost of the precondition. Okay, so new cost is equal to infinity. So current cost and the new cost, we're both going to say, hey, to load cargo, rocket, and NOLA, it's still infinity, right? So not at cargo. That's the effect. At rocket NOLA, at cargo NOLA. Yeah, that should have been 0, 0, right? I don't know. I don't think that was right. Okay, so literal is in cargo rocket. Okay. The preconditions at rocket NOLA. That should not equal, so that should be new cost plus the cost of that, so that should still be 1. Okay. Precondition of at rocket NOLA. At cargo NOLA should totally have a... Oh, it's not at NOLA. What? Is that the initial description of this problem? I mean, it totally could be, I just didn't know. Problem. Alright, so I'm just go here. See what happened here. Alright, so nodes. How interesting, right? At cargo, at that. So cost is going to be 2 for that one. And what's the other literal? It's already 0. Interesting. Crazy. So let's look at this queue. So this queue has values of two, 3, 4, which is interesting. How about now? Priorities. 2, 3, 4. Oh, okay, so you got another one. Nice. How about now? Another 2. How about now? I feel like we're close. Like, I feel like it's getting there. me just look at the values right quick. Guess I gotta kind of expand it a little bit. Can I just maximize this for a bit? Let's make this big right quick. Alright. So let's see, the plan is, oh yeah, those are fly, rocket, London, London, fly, rocket, London, London. Yeah, those not so good. I wonder which one it's grabbing. The highest one or the lowest one? In that case, it's going to go through a lot, right? Alright, let's put this back where it needs to go. Left-hand side here. I really think it's grabbing the highest ones first. So how do we make it grab the lowest ones? So I guess that's with the priority queue. Remove the item with the largest priority from the queue. I want it flip. Let's say the minimum priority from the queue. So I guess I just say, hey, give it, if best priority is greater than priorities I, then do that. Yeah, that's what I want. That's why it was giving us issues. So let's go ahead and go back here. That seems like a good place as any. Yep. So okay, if I look at my queue right now, we have priorities 2, 3, 4. So I really want to get the 2 out of there. So now, if I look at my priorities, yes. So, and that is load cargo NOLA, yeah. Okay, so if I look at my priorities now, we got 3, 4, 3, 2, 2. So I want to make sure one of those 2 goes away. Nice, so one of the 2's went away. So what are our values? Oh, no, not the values, the priorities. We got a couple more 2's, so maybe another 2 goes off the stack. I hope another 2 came off the stack. I can't tell though. So load cargo, then fly to NOLA. Yeah, that's great. More priorities. Yes, more 2's, which is great. If I look at the priorities, oh, we got a 0. Totally awesome. Definitely need to grab that one. Is that one gone now? Yeah. Sweet. It's even got a plan. Man, that is awesome. So the first one would be to unload. No. I forget how to read this. Alright, so null, that's okay. I think we load the cargo into the rocket at NOLA. Fly the rocket, yep. Then unload the rocket at NOLA. And then fly the rocket. Yes, that is exactly the plan. Nice! Alright, so HSP working. Very cool. So that is HSP. Nice. And that's all because of this heuristic we made down here. This sucker. Get cost. Nice. Alright, that's great. Okay, so I'm going to close this out. Let's see what source tree tells us. What have we done? So yeah, in the assets folder, for sure, we did all of this. Yeah, I guess I've been changing some stuff a little bit. Yeah, like that. Yes, all that's true. Okay, so benchmark, yep. We did start using the rocket domain in the benchmark, so yes, those two are true. What else? BFS planner. Yeah, we just put the breadth first search planner on there, not for any great reason, just so that we have it. So yeah, that's what we'll use. We'll use the breadth first search engine, just in what am I trying to say? In Sokoban, right? So we'll do the breadth first search, so you can kind of just see what's happening. Then we do the HSP, and then maybe even try to fast forward, maybe later. I don't know yet. Haven't got that far through in my thought process. Okay, so that's HSP. Yeah, I don't know if I need the properties. Do I need the properties? I think I need the properties. Okay, yeah, put the conversion util in the planning. State space node. Yeah, that's all good. Yeah, I know I'm screwing up. Alright, it's all there. I think I got it. Alright, so it's all there. I'm gonna go back here to my stream, wherever that is, this one. And what did we do here? Added bunch of PDDLs to Unity, but many don't work. Implemented HSP and BFS planners, and yeah, I mean that's exactly what I did, and this is great. Alright, so I'm going to commit this, and that is it. Alright, so I am going to close out this stream. Thanks for watching. We're getting there. A few more days, we'll get all this stuff done. We'll have HSP, breadth first search, plane graphs, all of the stuff kind of working in Sokoban and or just in general in Unity. So yeah, very exciting stuff. If you